Benoit Rittaud. So let me welcome you all for today's session. And we are very happy that Professor Benoit Rittaud is here for the second time. And he is from France. And you see, the thing is, there are very few people who are interested in connecting with mathematics. Oh, record. We came to know that he has also written a similar book, and this is also a good opportunity for advertising that book also. Okay? So, and it's also a good opportunity for you to learn French. Okay? La assassin de échecs. Chess. Oh, chess. Okay, okay. So here is the book. All right. Okay, so maybe, we are waiting to hear his lecture. So please start your lecture, sir. Thank you very much for.
So thank you, Professor. Thank you so much for our invitation. I'm very proud to be here. I'm also very proud to be here for the second time, meaning that the first time was not that terrible. So really, it's a really great pleasure for me to be here today. And it's also a pleasure because part of my work, well, I am a mathematician for one part, but I am also interested in mathematics and interactions between mathematics and the society and the vision of the world, and in which way mathematics can be helpful to understand the way we see the world, we understand the world. And there is a famous tale that probably many of you already know. You will tell me when I will tell you it. I will tell you it to you, and then you will say. I will ask to know how many people already knew the story. It's a legend from the old ages, and it happened in India, but in mythical times. It's a king, generally named Chiram, and an old king who was very successful. His reign was prosperous. He won every wars he made. The people were healthy, and so he didn't know what to do, and his life was so boring that it started to become painful for him. So his minister, in general his name is Sessa or Sissa, tried to find out what could be helpful for his king, and eventually he invented the modern game of chess. And he showed it to the king, and the king said, "Oh wow, what a wonderful game! I want to become a professional in this game. That's fine." And then he forgot that his life was boring, and he was very happy. And as a reward, he said to his minister, "Well, ask me whatever you want." And Sissa answered, "Well, what I want is 1 grain of wheat for the first place on the chessboard, 2 grains of wheat for the second place of the chessboard, careful, 4 grains of wheat for the third place on the chessboard, then 8 for the fourth, 16 for the fifth, etc., doubling for each place of the chessboard until the 64th place on the chessboard." And so the king looked at him and said, "Oh, well, you can't be serious. That's ridiculous. Well, I'm a king of India. I'm very powerful. I can give you lands. I can give you whatever you want. And all that you ask for is, some grains of wheat. That's not serious." "Yes, my king, I just want that. Just want that, nothing else." "Okay, so go away, see my accountants. They will count the number of grains for you and, disappear." And then the accountants of the king started to count how many grains are to be for the reward. And they realized that at the 30th place of the chessboard, the number of grains started to become really big, really big, and so big that in the end it would be impossible to any people, any king, so powerful he might be, to provide so many grains of wheat. So, well, the end of the story is, well, there are different possible ends of the story. One of them is that the king eventually told to Cæsar, oh, okay, I cannot give you your reward, so I can only make you king, and, well, I resign, and you're king instead of me. And Cæsar answers, well, I have esteem. Well, I am. You consider me now. You consider me now as a wise man. So we're okay. Keep your throne, and that's it. Nothing to be done. There are other kind of ends to this story, of course, and there are many variations on it. So just as a record, how many of you did already knew this story? So we're in India. Because when I ask this in France, well, I'd say 10% of the people know it, and here it's more 50%, of course. So it's probably not from India. The story probably comes from Persia, but we don't know for sure. There are other ways to tell the story, and in the first version we have, which is from the 9th century. And it's from Persian origin. The story is quite different and more romantic, if you want. The fact that Cæsar get his reward doesn't come from the fact that he invented the modern form of the chess game, but of the fact that the king died at war. And he was the guy that should tell it to the queen. And to tell her the truth, it took a chessboard, the pieces on it, and play chess. And at the end, he put the king, well, I understand, sorry, the word is, put the king down. And so the queen understood, and this elegant way of telling her the truth was the origin of the reward. That to say that in the beginning, this tale was not really a mathematical tale. It appears it was a tale that was intended to prevent from self-confidence. You know, well, some grains of wheat, don't care about that. Yeah, think twice before acting. That was the main thing. But of course, nowadays, this story is more considered as a mathematical exercise. And the first question is, when you have a chessboard, 64 places, and you have to put grains on it, so 1, 2, 3, 4, 8, 16, etc., and it becomes really enormous. And how can we count the total number of grains? So on the first place, you have one grain, that is 2 to the power 0. Do you know this notation? 2 to the 0? Okay. The next one is 2 to the 1, that is 2. And then so this notation is, thank you. This notation is quite powerful because if we rapidly it becomes impossible to write the numbers, but 8 is 2 to the 3, etc. And more generally, a simple way to write the number of grains of wheat on the nth place is 2 to the n minus 1. So be careful. There is always a problem in this mathematical puzzle, is that the number of grains in the nth place is not 2 to the n, but 2 to the n minus 1. That's because on the first place, you don't have 2 to the 1, but 2 to the 0. So it's probably we should name this place the zeroth place instead of the first place. But, well, it's not the way we do, so let's keep the usual notation. And so we have 2 to the n minus 1. And on the last place, we will need 2 to the 63 grains of wheat. So, okay, we have a notation for that, but this does not provide the number. You can write 2 to the 63. That not. It's well, it's a very practical notation, but it does not tell you anything about the size of the number. And so we have to think to a way to count the grains. And the first thing is to take all the grains, put on all the places, and to get a number for their sum. How can we do that? So a way to do that is to consider that you have a 65th place. How about the 65th place? That should get twice as many grains of wheat as the 64th place. To put grains on this new place, we're gonna take all the grains that we put on the chessboard, made of the 64 first places. So let's start. So I take to start on my 64th place. That should get 2 to the 64 grains of wheat. I put first all the grains that were on the 64th place. Okay? I don't know how many there are. I'm not interested in that. All that I know is that the number I put there is half what I need. Okay? And so I have to put some more here. How can I do that? Simply take the grains on the 63rd place. Okay? 63rd. I put it on. How many grains are there? I don't know, but what I know and what is really important is that, again, putting these grains on the 65th place provides half of what I need. Because the full column here should get as many grains as on the 64th place, and the 63rd place only have half of it. Okay, so on the same reasoning will be true for the 62nd one, okay, and the 61st, and etc. Each time you put the grains on any place to the 65th one, then what remains is exactly what you just put. And it remains true till the last one. When you put the unique grain of the first place, you will lack one more grain here. That should be added to, and so we have proved that the number of grains we need here on the 65th place is the sum of all the grains of the chessboard plus 1. Okay? So we have a way, a mathematical way, simple way, to express the number of grains on the chessboard. It is 2 to the 64 minus 1. Okay? Understand that? And what's interesting is that in this way of presenting the problem is elementary. When you consider mathematics made by people who tell story in the 9th century in Persia, most of the time these people did not know much mathematics. So you have to find out the way they were considering the problem. Possibly you already know the formula for the sum of the first term of a geometric series Okay, but this is very modern way of writing things. You don't find it before François Viette in the 16th century. Here we are probably in the 9th century or even before. And even if you can find this kind of thing in Euclid 3 centuries before before the Common Era, probably this, in Persia, not so many people knew of Euclid or even Aryabhata here in India. So, so now we have a simple mathematical way to express the total number of grains on the chessboard. It is 2 to the 64 minus 1. That's good. That's way simpler than 2 to the 0 plus 2 to the 1 plus 2 to the 2, etc. plus 2 to the 63. That's a very shorter expression. But still, we do not know how many grains are there. How big is 2 to the 64 minus 1?